Okay, in this lesson we're going to look at defining the functions sine and cos on our unit circle. So we saw in the last lesson that we know that the unit circle is a unit circle because if we go, the radius is 1. So if I go out like that, that radius is 1. So we're going to talk about if we're at this point here. So point, I'm going to call it P. Now, when you get to this point, we would have got to that point by doing some particular angle in here. Now remember that we move anti-clockwise, so that's how I'm knowing which way to measure the angle when I look at that point P. Now if we have a look, if I went across here, like here, across the x-axis, so that would be, and then I go up like that, you can see that this would give you, at point P, it would have the x and y value, and its x value would be what we measured along here, and its y value would be the lift or the rise, wouldn't it, to the y. So if we go to look at the coordinate of P, we can see that we get a right angle triangle. So if I was drawing that little triangle along here, you can see that that would be the x value at point P, and this, and the side of here, that side of the triangle would be the y value at point P once we've moved up a certain angle. And then if we have a look and we know that that triangle there, that's 1. So if we know that's 1, so if you think about it, if we were trying to find this angle, we can see we've got a right angle triangle. So if you think of your SOHCAHTOA rules, this would be the opposite side, and this would be the adjacent, and this would be the hypotenuse. So if I was trying to find, say, y, so I could use the opposite and I can use hypotenuse. So I might say sine the angle equals opposite over hypotenuse, which is 1. So see, if I rearrange this, it would be 1 times sine angle equals y. So we can actually say that sine, whatever that angle, is equal to the y value. So if we were trying to find the coordinate of that point P, we know that the y value is actually sine whatever angle we've moved. So then also you can see with the adjacent, that would be cos theta. So adjacent, cos equals adjacent, which is x, over the hypotenuse, which is 1. So you can see once again, if we rearrange that, and this is how we get cos theta is equal to the x value. So when you're trying to find this point P up here, you can work out the x coordinate of it by going cosine and pressing the angle, whatever it is. And that's how we get that. So I'll show you a few questions on the next page. Okay, if you're asked to evaluate sine theta, sine pi or cos pi. So remember, that would mean we're moving anti-clockwise and pi is over here. So when you're asked to find the sine of an angle, and they're using radians now, that's why they're saying sine pi. When you're asked to find sine is actually the y value at pi, and so sine value is the y value at pi, and cosine is the x value at the angle you're at, so at pi. So if we look over here, so if we have to find out what sine is at pi, you can see we're at here. So sine, that the y value is actually 0. So this one's equal to 0. Now, if you look, what's the x value at this point? Well, we've gone out our radius of our unit circle, so it's actually -1. So you can see that it's at -1. Okay, so you can see we could summarize. So therefore, you could say if you're asked to find sine at pi, you know that's what the y value is at that point. So we're going to say 0, and cosine at pi equals -1. Okay, so just remember that the sine is what the y is at the point, and cosine is what the x is at the point. So if you're asked a few more questions, okay, so if I'm asked to evaluate sine 3 pi on 2, I know 3 pi on 2 is down here. And if they're asking me for the sine, they're asking me for the y value. So the y value down there, because it's a unit circle, so because that is a unit, that's a 1, so it's actually -1. So y value for pi on 3 is actually -1, so I can say it equals -1. If I'm asked for cosine, so that's the x value at pi on 2, so pi on 2 is up here, and if you have a look, the x value is 0 there, so I could say that is equal to 0. Okay, so remember that you have to move, if you're moving, the normal direction is anti-clockwise, but you can get questions where they want you to move in the reverse way. So if, for example, I said evaluate sine -3 pi on 2, what you have to actually do is move the anti-clockwise of the unit circle. So we're going to go around that way, and we're going to go 3 pi on 2, which would be like 1.5. So we're going reverse, there's 1 pi there, and half. So we'd be up here. So we've moved backwards 3 over 2 pi, and that brings me to there. So if they're asking me what the sine value at there, remember sine is y, and up there y is 1. So I could say that sine 3 pi on 2 is equal to 1. Okay, so that's another question. Now, sometimes also you might get asked to do you might go around the circle more than once. So what I mean by that, so I'm going to say sine 5 pi on 2, and what's that equal? So if I just showing you on the unit circle, sorry, being really quick. Now, if you remember, if we do one full loop of the circle, we get back to 2 pi. Now we want to do 5 pi on 2, which would actually be 2.5 pi. So I want to go all the way around, that would be 2 pi. And I want to have half, I've got half extra, so I end up here. So I'm at this point once I've done a whole lap and that. So because we're just to help you out, so remember 2 pi would equal 4 pi on 2, and I've gone another extra half, so I'm actually up here. So when they ask you, so you can really say that sine 5 pi on 2 is the same as 2.5 pi, if you like, or which is equal to sine, you could say you've got 2 pi plus a pi on 2. And so therefore, you know that it's the same, because once you've gone around the circle, you know it's the same as pi on 2, which is, what's the y value up there at pi on 2? Remember being the radius. So we're on them, what's y? So that's actually equal to 1. Okay, we'll go through some more with you tomorrow in class, but we will be doing exercise 14B.